You're in this session to talk about the intersection of enterprise asset management and industrial IoT. Just to go through the agenda, my name's Ralph Rio with ARC. Just to go through the agenda with you a little bit, I'm going to do a short introduction, hopefully 10 minutes or less. Then each of the speakers will speak for 20 minutes apiece. And at that time, we'll have the Q&A session. The speakers will come up, and the suppliers who help them with their solutions will also join them on the stand. And we'll have 6 people then be part of the Q&A session. So, IoT. The main driver, this survey was done a little over a year ago, and of course, there were a bunch of questions. One of them was, why do you like IoT? Why are you adopting it? I'll just point out that the main driver is predictive maintenance to reduce unplanned downtime. Now, we do other surveys also. This one was just a little under a year ago, and we asked people, why do you have an EAM application? And this also means, why do you do maintenance and have a maintenance situation? Again, same type of result. Number one top item is reducing unplanned downtime, improving equipment uptime. So there is a synergy there, at least from a motivation viewpoint, between EAM and industrial IoT around predictive maintenance to reduce unplanned downtime. Now, I want to talk about this in a little bit more detail because some of you who are familiar with historians will argue with me and say, Ralph, we've been doing this for decades, looking at process data, using that to, as part of a predictive maintenance program to anticipate failures. The thing I want to point out here is that the historian traditionally, just by the nature of it, pulls data from the control system and tends to have just process data. With industrial IoT, we're pulling data directly from the equipment, and that gives us the opportunity to have equipment-related data in addition to the process data. The combination of the two allows us to do new things in the area of overall asset performance management. So another area of our research, as we talk among end users, unfortunately, I've found that the reliability department, the maintenance department, and in a certain way the technicians too, operate as separate silos. And when we asked the question in that survey about how do you communicate issues from the reliability group to maintenance, for example, the most common answer was ad hoc. And what does ad hoc mean? That means that I'm walking down the hallway, I see Joe, I say, hey Joe, we just found this problem with that piece of equipment. Maybe you want to send a maintenance tech to it, or send an email, or something like that. And obviously, when it's ad hoc communications, a lot of things can get lost. So this is managing the business process. So we're highly recommending that an alert be sent to your EAM system when you determine that there's an unhealthy asset out there. And all the EAM systems have a way to accept flags or alerts, then automatically generate a work order for the planner to approve and then schedule. So stuff doesn't get lost. I can tell you, honestly, I've had several conversations with reliability engineers, and they're all happy and proud because they forecasted the failure of a piece of equipment, and it failed exactly when they forecasted. And that isn't the point of reliability. The point is to tell somebody in maintenance so it gets repaired. And that kind of overcomes that ad hoc communications, that kind of link. And we're going to extend this also into maintenance, maintenance technician. Unfortunately, the most common mobile device is paper. The work order is printed, handed to a technician who then goes out and does the work, hand writes on the work order what was done, and then it goes usually to a data entry person later on. And studies have shown that if you have a form with 80 characters in it, handwritten out, and go through data entry, there will be a 10% error rate. So that means that, whether you realize it or not, when you have paper-based work orders, the data in your EAM system is got a high error rate. And when that occurs, people don't trust the system. And they wind up with manual workarounds and stuff like that. They may trust it to keep track of inventory, but that's about it. When you get into a mobile device and the data is collected as part of the work process of that maintenance technician, then it is going to be more accurate. And when you have accurate data in the EAM system, people become willing to use it as a proactive planning and scheduling tool to improve overall reliability of the production process and the equipment. So we are, just to summarize, highly recommending automated business process management, particularly when you get into industrial IoT, predictive maintenance, and that thing starts raising flags on a more regular basis. You don't want that stuff to get lost and not acted upon. So let me explain this slide a little bit. You've got production with its set of metrics, and you got maintenance with its set of metrics. It isn't that they're fighting with each other. They normally typically operate as two different organizations. The metrics are aligned or compatible, so they're not fighting with each other. But they're two separate stovepipes. I put a hole in the wall because they do talk to each other occasionally, but they're really not synchronized typically. And the thought process here is that when you can combine process data through the historian, process data having to do with production, with IoT data, which then brings in the equipment data, i.e. maintenance, this allows for much higher or new areas of process optimization. And we coined the term APM 2.0 as a new area for process improvement capability between using both process data and IoT data. That's the end of my talk, my introduction. At this point, I'll introduce Bill. I'll just remind you that each of those speakers will speak in that order, and then the Q&A panel will be joined with the sponsors, the suppliers who helped them out with their solution.